Are there any clues that ever talk about 30 down? And I see number 5 down. Says see 30 down. Or 5, so 5 down, see 30 down. When I get to 30 down, it says 3 times 5 down. And so that it tells me I can kind of look for which ones to go back and forth to reference. You can't do them in order. You have to go track down which ones that you can do. So yeah, you put that away. We can wait till tomorrow. Look at that. It's extra credit, so that is not on your priority to do that. So this paper, did you find it? Or did I have to? Mine's turned funny. Oh, I gotcha. Okay. So let's see. We got one finished, and I'm kind of thinking on Thursday we said, how about you work on 2 and 3? So let's go to 2. And if we did 2 together, well, then we'll just get caught back up. Y varies inversely with x squared. Inversely divide, remember? Y varies inversely with x squared. And y equals 1 when x is 3. But don't forget it's squared. So 3 squared is actually 9. Let's go solve for k. We'll multiply both sides by 9. So k is a 9. And then go back and let's make an equation for this particular number 2. That means we'd be working with y equals 9 over x squared. And it says complete an XY chart. X is, and y is in terms of what? -4, -3, -2, -1, 0, 1, 2, 3, and 4. You can, if you have your own right now, go type this into your graphing calculator. Go type in y equals 9 divided by x squared. And then go to the table. But I'm not going to use that because we don't really need it. Let's go put a -4 into our x squared. How much is -4 if we square it? 16, so that'll be 9 divided by 16. See what I mean? We don't need that silly calculator. And now let's go put a -3. What's -3 if we square it? 9. That would be 9 divided by 9. Most people call that 1. And if we put a -2 in there and square it, that would be 4. So that's just 9/4. And if I put -1 and square it, that's 1. So 9 divided by 1 is 9. If I put a 0 in there, that's going to be 9 divided by 0. Don't type it in, it'll blow up. If we put a 1 in there and square it, 9 divided by 1. 9 divided by 2 squared means 9 divided by 4. 9 divided by 3 squared would be 9 over 9. That's just 1. Or 9 divided by 16. Calculator table, you probably see decimals, I bet, don't you? Okay, that's okay. Same thing. And then it asks you to graph. And I don't want you to just go, oh, there's what it looks like. Off on my calculator, let's actually put some decent things in there. So our x's go from 1, 2, 3, 4, 1, 2, 3, 4, and we need y's to go all the way up to 9. So we're going to go -4 to 9/16. -4, but not up very far. -3 goes up to 1. -2 goes up to 2.5. -1 goes up to 9. 0 doesn't have any answer. 1 goes up to 9. 2 goes up to 2.25. 3 goes up to, oh yeah, 3 goes up to 1. And 4 is only at 9/16. There we go, some exact values.
What?
The graphs look like.
Well, do you have it or not?
line up there. Now we're ready for number 4. Number 4 says use your graphing calculator and sketch what each one of those is going to look like. You need to borrow a calculator? Come trade your phone. So if you need a graphing calculator, come get one, otherwise start type right away at number 4.
When it says sketch, you don't make it.
That's right, sketch. Otherwise it'd say with exact values, and exact values would be, counted off. You can still sketch it, but count it off.
Did you do draw? And it fell out. I put it down and it fell out of this pocket.
Everybody good?
Jar loose. Oh, you don't have that.
Finish stuff.
I think I should.
You cut up?
I was talking to you.
That's right, and you can do that, that's where we're at right now.
Oh, okay.
Okay? So, there you
That
are.
was mine. This one.
There we are then.
Here's my phone. That's what I was doing. No, I never did that.
I know, it's pretty sloppy.
That's all.
Never touches. This one, right?
Yeah. Draw. That's still wrong. Got me close.
Got the close, that's right. If you've got 4, then just go 1 to 5, and then we'll get them all up there. Just get the 5 instead. You okay? So, we'll just go to y equals. And then, get that one out of there, and go 3. Divided by x. I'll tell that x to be squared. And then push graph.
Yeah.
And then just go graph what you see. There's one too back here. Hey, you graph that. You got a phone? Go trade mine. Yep, use it. Bring me your phone. Those are still a different shape than that.
What?
Yeah, that's good.
You?
No, we'll have to, I did, from you on down,
That's one of
you
me.
know, something up, so you like to ask them.
Don't talk to me.
So they're all fixed now.
Don't talk to me.
And we've got that, and we will have to.
Oh, you know that song?
Yeah.
You ever watch that show?
Yeah.
Orange is the New Black? Pretty funny, dude. He's so funny.
Yeah, that's all chick flick.
I don't know if it is. I'll watch it with my mom. I don't care.
This will be good enough to.
Yeah, my mom will watch it.
Huh? What?
What do you mean what? You're like a child now.
What do you mean?
He's annoying.
Turn around and pay attention.
How are we with our number 5? We got some
I
things
stayed
in
with
place
myself.
for 4 and 5 that you can tell the difference?
I hate you.
Uh-huh.
Stop. I'm talking.
Yes, you got it. So, and I'm watching you, I've looked over your shoulders a little bit, and we've got some 4 and 5 finished up here, so you can check in with the way that those
Alright.
look. So let's go, I don't know what happened to the numbering, but after number 5, you would think comes number 6, but it's not. Now you're looking at number 3 on your paper. So there was some auto numbering or something that went kind of funny. So after 5, we're looking for list 3 conclusions from all those graphs, really. It said above, but that was just the previously. 3 conclusions about when k is positive, when k is negative, and the difference between x and x squared. So what could you tell me? Pretend you and I are talking on the phone too, so that you can't point to something. So what can you tell me about, what's the first one say? If k is positive, what can you tell me?
It's gonna be on top of the graph.
For which one?
Above.
And what do you mean by top? So when I'm looking at this one, here's a k that's positive.
When it's x squared positive, they're both gonna be on.
Okay. So I'll say with y equals k over x squared, if I'm going to say k is greater than 0, that's my fast way to write if k is positive, then what happens? Then
About
so on y equals k over x squared, if k is positive, what were you going to say? Finish up, and what did you say?
Above the x.
And here's what you're looking for. Here's the math words. Everybody see 4 sections? Prefix that means 4 is quad. So these are called quadrants. So here's quadrant 1. Here's 2. Here's 3. Here's 4. Does that give you some language to use? Then your graph is
quadrant.
graph is in quadrant 1 and 2. Yep. On y equals k over x squared. K is positive, then your graph is in quadrant 1 and 2. We just need to come up with 3 things. There could be more. We just need 3. There's 3 bullet things.
That's right.
Yeah.
Shouldn't that be 1 of 3?
We were looking at the x
Oh,
squared
sorry,
one.
I didn't see the square.
Yep, and that's, I'm glad you said that, because see, then that points out the difference between the x and x squared. Well, let's do that one then next. With, that'll call out the difference. With y equals k over x, if k is greater than 0, then graph is in quadrant, should say quadrants because it's plural, well, quadrants for k over x.
1 and 3.
1 and 3. 1 and 3. Quadrants 1, 3. say something else, somebody? This side of the room. Josh? Just do something similar. Which one you want to do? You want to do k over x or k over x squared?
K over X.
Okay, so let's say with y equals k over x. We just talked about k is positive. What if it's negative? If k is less than 0, that's negative, isn't it? Then graph is in quadrant, where is it? If we're doing the y equals k over x, k is negative, what quadrant? 4 and 3.
2 and 4.
So it's just a k over x, so those are your ones on the left.
Should negative
3 and
k,
4.
right?
So if we're on y equals k over x,
Oh.
and k is negative, it is in 2 and 4. We're in quadrants 2 and 4. And we could go get the other one, but it just asked for 3 things, so we'll start with 3 things. Question 4. When will, now you can look at any of them, when will your graphs cross the x-axis? Show me ones where your graph is crossing over the x-axis. On either page, the front or the back. What? Never. They're never crossing the x-axis, never. But what's it got another part 2 to that same question though? Number 4's got a part 2. When is it crossing the x-axis? That is never. When's it crossing the y-axis? Never. For these two types of graphs, they are never crossing the x or the y-axis. Never, never, never. So number 4's got 2 never answers. Never, never. Never, never. Number 5. Somebody try to say that word. Asymptote. Asymptote. Starts with a short A. Careful. Oh no, I don't know if it's a good idea to walk up to somebody and say, "Oh, stop being an asymptote." I don't know if they think that's funny or not. There's a math joke in there somewhere, isn't there? I don't know what it is, but on some of those puzzle worksheets, somewhere, there's a math joke to that somewhere. But the Y doesn't make a Y sound. It's like a short I, so it's asymptote. The P is silent. That's a lot of letters. If you try to say all of those, you don't really say asymptote.
Let's try there. Going back to number, I guess would be 3.
I know which 3. Yeah, in our conclusions.
Yeah, the one where we're working with the quadrants. Would it be fair to say that doing it that way is kind of the shorthand, mathematical shorthand version of not doing the XY charts to figure out which quadrants they fall in?
Yeah, I know. Just learn the pattern. Yeah, just learn the pattern. Instead of making all those XY charts on the other side like that, follow the pattern and just, so it's called parent function. When you just know the general shape, the phrase for that is parent function. Here, and I'll show you. You guys know parent functions. Show me y equals 2x squared with your body. Y equals 2x squared. 2x squared. Because you know what a parabola looks like, and that's called the parent function, just that general shape. Now, I don't know how we're going to do this. Somebody can be creative. What would y equals 2 over x be? I don't know how to do that. I wish I could think of a way. Maybe I know, that's what I thought. You know, y equals 2 over x. You kind of need that first and third quadrant. Kind of. I don't know how to get that, you know, those arcs in there. I don't know. Maybe you have turn this way. Turn this way. Is that looking pretty good?
Walk like an Egyptian.
You know? Or y equals negative 2 over x, and you can go like this. But just the general shape of them, it is a shortcut in showing what those parent functions, you know, look like there. So, let me show you what an asymptote does. Here, we made a picture last period. See the red lines up here? The red dotted lines? Those are asymptotes for the blue graph because it never quite gets there. Down here, it never quite gets there. Over here, it never quite gets there. It never crosses the red line. It never quite gets there to this red line. So they don't have to be the x and y axes because it might be shifted. But you see how this graph will never cross over here? And it's never going to cross here, and it's never going to cross here, and it's never going to cross there. Those red lines are asymptotes. Anybody got a good way to say that, to describe that?
X and Y lines.
Untouchable lines.
I know. See, it's hard to say, isn't it? I don't know a good way. That's why I'm asking you all. Untouchable, boundary. I think somebody in the last class said boundary. I think we came up with the word barrier. They are always lines. But they're lines you never cross, so you're never going to touch them. They are untouchable. So if you think you can word that okay, if you think you're better off drawing a picture of that, okay.
So the fluid four-way stop, how about that?
Well, yeah, it does kind of look like, doesn't it? Looks like you're coming and you're turning left.
You can't cross over the stop.
It does kind of look like that. Hey, you always ought to be in the left lane. If you're turning left, you ought to be in that farthest lane.
And it can be anywhere on the...
Well, apparently you've not been behind me while I'm driving, because sometimes I do cross over those lines. Something catches my attention over on the sidewalk or something, I might look over there. And then you might just simply do something like this as a graph. Maybe a yellow truck, I don't know, showed up. Let's see how the pink shows up. Maybe on a graph, maybe you want to do this. You got highlighters there on you. Maybe you just want to highlight and label something that's an asymptote. But remember, Wednesday you get to use your notes on your quiz. So anything you can do for yourself to help yourself out, it's a good idea. Everybody okay with asymptote? Got something down? Maybe some words or a picture or something? Asymptote? Boundaries, yeah, I like the dotted lines, boundaries. Do you want to try to say that next word? The H-Y word?
Hyperbola.
Hyperbola, Hyperbola, don't say hyperbola, it's not a bowl.
Or even
Hyperbola. Hyperbola. You can accent the P-E-R, hyperbola. Walk up to somebody and go, hi, hyperbola. Hi, hyperbola, hyperbola. These are the hyperbolas. These shapes like this. All of these hyperbolas. Hyperbolas. They have two branches. They are. How would you? So opposite, I know what you mean by opposite. Somebody else might call this opposite though. So what's the word maybe that describes meaning this as opposite?
diagonal.
Diagonal, maybe? They have diagonal branches.
Or you say when they're in quadrants 3 and 1, 2 and 4.
That's right. Hyperbolas are in quadrants 1 and 3 or 2 and 4. Exactly. Right. Hyperbola. So, something else you might say is it's when you graph y equals k over x. And they do this or they do this. That's hyperbola. They have two branches, that's what those parts are called. Now we're going to get that page put in your book. And here is, you can do whatever you want. Here's what I found helpful, because I wanted to be able to get to all of it. So, it's up to you. If you got a better idea, that'd be great. But it's copied upside down on purpose. So I just took my page, and remember you're on the right side of the page, you're on page 32. I just left it open and made it right side out just so I could read it. And then later, I went back and I folded it, but I folded it so I left a little edge out here so that I could staple it or tape it. So that, watch this, see this is clever. So then, once it's like this, that's the only place that I attached it, that upper left-hand corner. Then when I want to see the back, all I gotta do is fold it up and now it's upright. It's upright and I don't have to stand on my head to try to read it or turn my book upside down. This will be, and so you will want to get your table of contents updated. This is page 32 right now. If you always go on the right side. There's a few staplers around the room. And then if you notice, that's where I put my title then, because since it was upside down then, by the time that I folded it, that's where I put the title of Graphing Inverse Variations, right on the top of that. Or you could decorate the page or something. So let's see, I went like this, and I just stapled right there. That's the only place I stapled. And then, later, so that I didn't cover up that staple so I could still see it, I did this. I actually moved it up here, and then I just put my title here. So I just stapled right there, so I could open it up and see it, and then if I want to see the back, all I gotta do is that. Where's the stapler somewhere? I thought the stapler held it in place nice.
Wait. There's no more. I broke it.
I'm lost.
Yeah, dark now. You seriously stapling that?
There it was, because it's folded
Here.
backwards. Right? But then
Sure.
6 is upside down. Right? That's okay then.
No.
Yeah.
No.
What do you think?
Don't.
That's your favorite.
Dude,
Good?
copy, bro.
Perfect.
Is that right there?
Hey, can I see
Yeah.
the stapler?
Yeah.
Stapler? I need the stapler, sir. Sir. Sir.
Stop.
Yeah, that's it.
Don't talk to me. Don't talk to me.
He got you.
I think I might have staples.
Here.
My favorite
Okay,
staple.
that's nice.
Can we start with this? Oh, shit.
Look at this little Rebby stapler. Remember those little red staplers?
You wanna do it?
You remember those little tiny red staplers? Everybody's got one of those.
I was a baby.
Big foot. Oh, big foot.
The nice thing about this is
Figure it out.
it fits in your hand.
I can't even see the camera. See the shade. I can't see the camera. What do you mean? I don't know where it's at. Where's the camera? I'll guide you.
Hey, I was laughing.
You're a soccer coach?
I am a soccer. I was laughing because you guys were simultaneously yawning. You didn't know it.
Yeah, because I saw you laughing over and I'm like, what? I'm tired.
It was like literally exactly the same time. Yes, I'm a soccer coach. You have a problem with that?
What?
You have a problem with that?
I just figured out something more manly.
Yeah.
Why? See, when people make statements like that, that just, you don't know anything about soccer.
I know. I went to a soccer game once. Soccer's
I
good.
promise you.
Soccer is pretty fun.
I'm all man.
When I was in Haiti, I played it there. Soccer's for girls.
My finger.
Yeah.
Like we did like
Girls
monkey in the
play
middle thing.
rough, like worse than
You got
football
like a
players.
bunch of people on the side and all that, and it's like,
Or
and
just
then
kidding,
there's one
I
person
don't
in the
know.
middle, and you gotta try to pass it to someone, and the other person, if they touch it with their foot or blocks it, then they're not
Those
gonna.
kids any good?
Yeah, they're really.
And you don't know
Some of
anything.
them like professors, like.
Do you have a soccer ball or you guys playing with rags?
Soccer ball, yeah, we brought the soccer ball.
I wasn't joking, that's what a lot of third world countries do, they play soccer with rags, they ball them up,
Yep.
kick it around.
Alrighty.
So boring.
Let's make page 31.
It is.
And it's mostly just some graphs and some labels. So make big, nice, pretty, clear, highlight, lots of descriptors. Same title, graphing inverse variation. Would you put 1 on the left, y equals k over x, and then on the right, y equals k over x squared.
This is for
The left page, yep, you got it. Just like that. I started at page 31.
Can we make that?
Uh-huh.
I hope it's.
Thank you, a great big heading.
Do you want to make Mr. Salad mad?
I do.
I could tell.
There. There. There you go. What's he gonna do? Why?
And we got two cases underneath each one, when k is positive and when k is negative. So let's say, if we have y equals positive k over x, and I don't know if you got one room vertically or horizontally, and let's do the graph for y equals negative k over x. My graphs look little, make yours real big, fill up the whole page. And if it's positive, those are where your hyperbolas, first and third quadrant. If k is negative, hyperbolas 2 and 4. But you got the whole page, you don't have to make yours little like mine look. Make sure it's clear when k is positive and when k is negative. Maybe even just down that side of the page, maybe you want to remind yourself over here, hyperbola. But not the ones on the right, they're not hyperbolas. And we have two of those. We have when y equals positive k over x squared. What that one looks like, first and second quadrant. I'm going to do mine beside it because I don't have any room underneath. If y equals negative k over x squared. Here. Here. Some people call this inverse square curve. But I don't see that all the time, but everybody calls hyperbolas, hyperbolas, and parabolas, parabolas. Those are the two words that you need. Parabolas and hyperbolas.
I know. I'll hit him if I get a chance. That's the first year I've seen. There's always a flyer. Here down study skills.
There was one in our ag class, like 3 weeks, finally killed it.
And
What's that?
Just getting killed, we finally killed it.
Wow, they keep coming in the house.
are you seriously doing
It's not
that?
like
You
they
don't
have
do
to
that
have one every 2 days.
What?
How'd you do that?
They're slow, you know.
Shredding.
It's just like,
Shredding?
you know, 70 years old,
Shredding.
slow.
Anybody know about that?
Deer the other day, because deer season started, and I got
Yeah,
bit by
that's
a
just-
mosquito. I've never been bit by a mosquito when I was deer hunting before.
Because the way they're cold. I know.
Crazy.
They're better than they were
Yeah.
like a month ago.
Nepal.
It was only for like 10 minutes.
Yeah. So a couple of days given up like a month ago.
Yeah,
How do you remember?
because I used to hang out with her all the time.
You got nice pages
What?
for graphing inverse variations? You got
Oh,
nice
yeah.
pages?
Very nice.
Okay. Those look pretty good, the one on the left. I like the black way it separates it, and that those are called hyperbolas.
Terrible.
They do look nice, all these on this side of the room. What do those look like over there? I think this side of the room might look better.
Ooh.
I didn't make it over there, but it's gonna be tough to beat what some of these over here look like.
Yeah, better catch up on
They
it.
do, yeah, everyone I see. Everyone I see over here looks good.
We have some auditory learners over here.
What's that mean?
They're
That's mean.
less inclined to use the like a lot of people who are visual learners like that color contrast.
What? I'm more of a picture learner.
What's the visual?
And visual learners.
Yeah.
Picture learners.
learners.
Now, just because that's probably, I bet, that might be the last thing we actually put in your book, probably this week maybe,
Yes.
doesn't mean that it's not helpful, because especially look at Wednesday. Wednesday, when you go to take a quiz and it says something about a hyperbola, what's the definition of a hyperbola or an asymptote, get out your book and use it, because you can't on quizzes. So we are finished with that, but that doesn't mean we're finished, because
Yeah.
now you're going to practice. Use your book. You don't have to have graphing calculator to do this, because you guys all stored it up here. You know this.
Yup.
You can use graphing calculator if you want. You can use your brain. You can use your nose.
You're terrible, dude.
Hey, how'd you guys do Friday?
Terrible.
Yeah.
Terrible.
I missed you 8:30 on Friday after I saw you.
Yeah, I got signed out.
You did?
Yeah, I had to go home and get my stuff.
Everybody good? You got a worksheet?
I
Got a
left all my
homework?
football stuff at home.
Yeah, I need help.
Don't think you do. I don't think you do.
Oh, yeah, you don't have to
What is the hyperbola?
I can't say that. Hyperbola.
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 The part.
And the
Hyperbola.
hyperbola are called.
What do you call those two pieces? I used it once. I used the word. What would you call? You had to come up with a name. What would you call?